In this video, we will be doing a brief overview of ROS features so you can understand what it does at a high level. First, let's start off with a robot. This is a very simple robot with 4 wheels which allow us to traverse our environment. We have a motor which controls the left side of the robot and another motor to control the right side of the robot. We also have a vertically mounted camera with a motorized base so it can look around. We also have other sensors on board in the enclosure. Here we have a GPS position sensor, and here we have an IMU to tell us our robot's orientation. So what exactly does ROS have to offer when it comes to developing our robot code for our test robot that we have here? Well, the first thing we have is called the ROS Master, which is essentially a server which keeps track of all of our robot processes. It keeps track of what robot code we are executing, which are called nodes. Here we have 2 software nodes, which initialize with the ROS Master and can then open up communication pipelines with each other to send and receive information. One of the primary ways communication is organized is through publishers and subscribers. Here we have 2 nodes, a camera.py node, which wants to make available images from our robot camera. So it publishes these images to anyone who wants to listen in or subscribe to this particular data. These communication pipelines are referred to as topics. In the case of our robot, we can have a topic called front camera, which publishes information which is referred to as messages, and in our case, the message type is an image. This architecture is very scalable, such that one publisher can send messages to multiple subscribers. A way to think of this is the way common video streaming websites are organized, such that subscribers are sent new videos when they are published, and their channel name is like a ROS topic name. Another way to communicate between nodes is through services. For example, let's say we have these 2 nodes. One node wants to tell the other to turn the camera on our robot 45 degrees, so it sends a request of 45. The second node then processes the request and it will send back a reply. In this case, we send an image taken after the camera was turned. This is called a response. The third way to communicate between nodes is through actions. In this scenario, we want one node to command our robot to drive to a certain latitude and longitude coordinate to take a picture. We call this our goal. As the second node processes the proposed goal, it will send progress updates. In this case, we will send back data on how far away we are from the goal. This is called feedback. This feedback will continue to publish until we have reached our goal. Once we have reached the goal, our robot will send the picture, which is the result of the action. Another feature of ROS is the Parameter Server. This server allows for the storage of variable values, so you can easily update them. For example, if we decided to change our robot to have larger wheels, we may have to reflect those changes in our calculations done in our code. Rather than going into the code to change this, we can instead tell the Parameter Server the specific wheel size and have our code reference the value from the Parameter Server. There are going to be times where you want to collect data from your robot, in which you will probably want to create a bag file. A bag file can subscribe to multiple topics and record the data as it comes in. After you are done recording this data, you can play it back and have those recorded messages get published over the same corresponding topic names. It is worth noting that ROS code is organized as packages. These packages will contain all the code for particular robot functionality. These packages can then be easily copied and redistributed to other developers who want to use it. Then, they can use that same set of code for use on their own robot. Okay, that was a lot to take in, so let's review. The ROS Master keeps track of all of our robot processes. Specifically, they keep track of our nodes, which is executed code utilizing ROS. There are multiple ways our nodes can communicate with each other. One of the most prominent ways is through publishers and subscribers, in which nodes can publish data for subscriber nodes to process. Another way is through services, in which one node sends a request to another node, which then sends a single response per request. One more way to communicate between nodes are through actions, in which one node sends a particular goal for a second node to achieve, and that second node will continue to send feedback until the goal is reached and the result is delivered. ROS also comes equipped with a parameter server, which acts as a central hub our nodes can reference for robot parameter values, which may need to be modified in certain situations. Bag files are used to save data being published by the robot, which can later be played back on the same topics to simulate the data as it was experienced by our robot. Lastly, our code we develop for ROS can be organized into packages, which can easily be distributed for others to use. Alright, with that, you now have a glimpse of what tools ROS provides with your robotics code development. If you liked this video, be sure to like and subscribe to see more content like this. If you want to learn more about using ROS for your own robotics development, check out the Intro Robotics Developer Course on Udemy, link in the description below.